Sweet.
All right, thank you.
Awesome. Okay, yeah, so I'll kind of kick us off. So this is, our session here is facing SSRF and downstream asynchronous workflows. I'd say the session's going to start like pretty high level. Just what is SSRF? You know, the introduce concept for those not familiar. We'll get into like some sort of like classifications like it's showing the agenda right now. We'll kind of like categorize it, give different like types and like categories of server-side request forgery. Talk about mitigations and bypasses, and then we'll kind of get into like the kind of more emphasis area of the session, which is specifically talking about, I guess I'll kind of spoiler, miniming, using SSRF to establish like minimum scenarios, and then exploring like the responses as different points into applications. We're gonna show like a recording of like a demo lab type setup, and then we'll just have fun. Cool. Right into it. So this is like the Who Am I section. I'm David. This is John, as you can probably tell from our pictures. I'm, currently just kind of in between roles, so he's currently independent, but he'll be joining different thoughts around here shortly. John, you want to introduce yourself here?
Yeah, hey everybody, my name's John. I work at RSM in Des Moines currently. I've been there for 3 years, mostly doing cloud application and embedded security. Into the kind of home labbing makerspace personally, and containerization recently as well, even with virtualization to containerization.
Right on. Okay, so we'll kind of get right into that primer area.
Sure. So, just quick poll of the room. Who knows what SSRF is? Server-side request forgery. You know what it is. You know what it is. You have an idea of what it is. You know what it is. Okay. No idea, Ted? Cool. So server-side request forgery, there's the OWASP definition. If I had to boil it down, it's basically an injection point on a web application that accepts a fully qualified domain name. And then the application uses that fully qualified domain name to reach out to some arbitrary place on the internet. So essentially you can leverage a web application as sort of a proxy for you. And we talk about different sort of loosely defined classifications. To tie it to some CWEs, you could have a redirection with an open redirect. So maybe you have input validation on the domain of like your first injection point, but if that domain has an open redirect somewhere, so like in a perfect world, you control the whole URL. You go anywhere on the internet. Sometimes you do have validation on like the domain name, but in this case you can still see SSRF if that domain has open redirect somewhere. So like the controlled domain / some page that's got an open redirect can still lead to SSRF downstream. So open redirects included in there. Local file inclusion, right? We talk about reaching out to something on the internet or something on a container or something on a virtual machine. Instead of doing HTTP, what if we do file : //SMB, any other protocols that may work as a resource identifier, a URL. Also, weak authentication ties in here. We could pass like, if we're trying to do SMB, we could be like user at password SMB, potentially accessing internal resources. And then we also mentioned misconfigurations such as the instance metadata service. So like in the cloud, you have a magic IP address that delivers metadata about the instance where that resource is hosted. So if you use a vulnerable version of IMDS or misconfigured IMDS, you could potentially access cloud secrets via SSRF. So that's kind of a blast radius configuration. So like I said, we loosely define kind of 3 categories of SSRF. I don't think this is really documented anywhere, but we talk about transparent, semi-blind, and blind SSRF. So transparent SSRF is the SSRF you're familiar with. You have an input validation issue, send a request to an internal or some other resource on the internet, and that response comes back to you. So you talk to server A talks to server B talks to server A, and server A sends the response from server B all the way back down to you. It's completely transparent. You can see the request you made, and you can see the response you're getting from that external resource. Semi-blind would be that you can see something like a domain hit, right? So if you're using a collaborator, you may not actually see the HTTP request because of network firewall rules, like egress rules on the web application. But you may know that something's happening because the server still does a DNS lookup. Like, we're not going to block egress DNS, or highly unlikely that we would. So that's semi-blind. It's like, I know something's happening here, but I'm not seeing the responses. I'm just seeing it hit my server, maybe a DNS request or something like that. And then a completely blind is a completely restricted outbound network. So, or I'm sorry, so that would be blind, right? So the DNS, yeah. So the blind would be maybe all you see is DNS because you have the egress filters. Semi-blind, we say like you don't see the response from B, from server B, right? As you, so you can see the request, but maybe not the response. Cool.
In summary, like for the purpose of this, our loose definition is that transparent means you see both the request outbound and then also the response from whatever you're interacting with. Semi-blind would be that you could see like the request, but you won't necessarily see the response. And then in like a blind interaction, like we can't even see the request and we just don't know what the response is. So we're gonna have to rely on some other like indicator that like that blindness is occurring.
Yep. Thanks. So we've been doing a lot of talking about SSRF. This is what it looks like. We'll talk about server A, server B. So in my quick analogy, server B is that remote system all the way on the right. The target server is the web application you're testing, and obviously the local system is wherever you make that call. So you have an injection point that you identify on target server. You call it with 1, and you pass remote testing system's domain name. The server itself reaches out to the remote testing system, and this is a blind scenario where the remote testing system or internal resource or whatever you're trying to hit with that URL goes back to the testing server and then ultimately back to the original caller. So that's pretty much SSRF blind. This should be kind of baseline as we start to talk about the asynchronous workflow. I'll pass it off to you.
Okay. So yeah, in like a very high level summary, we're going to have some sort of input which coerces an interaction with ideally a system that we control or a system that we don't control but want to have some sort of access to. We're going to talk about protection mechanisms and then like some points of failure in those protection mechanisms. This is actually, in my opinion, like a very interesting type of approach to defense, because a lot of times when you see SSRF, there's like actually like a business use case as far as why there needs to be an interaction. I think one of the classic examples is like a webhook or like some sort of like profile, like updating like the avatar of the profile, I think is one of the very traditional examples. And that functionality like exists for a reason. So like how do you actually defend against it and prevent it from unintentional use? So really at its core, one of the first and foremost defenses is, as with pretty much any vulnerability out there, input validation being like your first line of defense. Ideally being like very strict allow listing of which targets you're allowed to do so. One of the points of failure is that you're not using allow listing, but instead you're using like deny listing, which just isn't as firm in my opinion for defense. There's also a lot of like really interesting, honestly, behaviors with URIs and parsing of URIs in particular, which could lead to weak validation upon URIs as far as how they're evaluated. The second line of defense, and this is probably less so incorporated from what I've seen, and kind of the premise of the talk, strict response handling as well as input validation. So the question here becomes, like, if we do solicit some sort of SSRF interaction, how does the system respond to whatever comes back from it? So there's obviously going to be like an expected pattern of what comes back in response. Maybe that's an image. Maybe you're working with a third-party API, and like that, like JSON structure or XML structure is expected in a certain way with certain patterns. But what happens when it's not that? Because a lot of companies and a lot of teams will put input validation upon like the inbound request, and then once that input validation is done, then everything is trusted, except when it isn't. So response handling becomes a pretty important protection mechanism. System isolation really comes down to like network access controls. This is again where you see a lot more focus on ingress controls as far as like firewalls go, but usually a lot looser egress filtering which makes it a lot easier to get those at least semi-blind interactions where you're allowed to get the request out to an external system. And a lot of the times there's not even necessarily a use case for that to happen. So it's a perfect example of where like firewalls can be enforced to just completely isolate that workflow such that it's not even possible to interact with other systems. Then lastly, strong authentication controls. If there's any sort of like implicit trust of internal systems, which isn't, I wouldn't say super common these days, but like there's a lot more trust within network boundaries than there is between network boundaries. You could have some sort of like authentication failure or authentication weaknesses, as well as, like SSL and TLS. So ways to essentially verify that the connection you're making is with the party that you're expecting to make it.
So with strict response, one like clarification, maybe that didn't come up as clearly to me when I heard it, right? So if we have an input validation issue from the caller hitting the API, right, past any URL, that's kind of where we generally stop, where a lot of app testers might stop. But you got to think about, hey, I can pass attacker-controlled domain, and I can control the response, right? So like David mentioned, hey, once that request comes in and we do our input validation, whether how strong it is or not, we trust the response from attacker-controlled domain, or potentially. So now we have another injection point in that response to the web app. Is it expecting an image? Is it parsing the image? Is it running a PDF generator? What is it doing with the data that comes in the response? That's an injection point for an attacker that follows on SSRF.
Exactly, yeah. So yeah, pitfalls. I'll kind of, and I pretty much alluded to a lot of these already, but I'll kind of elaborate on, one of my favorite examples being the URI parsing or the URI validation, because this is like where almost all that input validation does occur. I've seen like some weak implementations where there's like basic string matching or like basic like leading with https://myalloveddomain.com. But when it comes down to reality, like URIs are weird, and if there's like some sort of weak validation, we might be able to still control what system is interacted with by messing with like this post portion, which might not be the user info portion. So, for example, if a validation pattern was, my URI has to start with https://example.com, a URI that's https://example.com at my example domain, my other domain.com, passes that weak validation control, but still makes the connection out to our own system. So there's, similarly some weird stuff where, the @ symbol, the colon, the question mark, pretty much any separator within a URI becomes a way to tamper with the URI and cause some questionable behavior. So kind of one of those fun examples. And then also as a second portion of input validation, if they're not actually resolving domains, you may actually be able to interact with internal addresses, because a lot of times we'll say, we'll want to make sure that the URI we're going to call out to is a public IP address. So we're going to deny anything that starts with like 192.168, anything like that. But what if we just have our public DNS record and that DNS record resolves to an internal IP? If they're not resolving the DNS record and then validating the address before that, we might still be able to interact with those internal systems. So some fun little shenanigans with input validation as far as SSRF goes. The response filtering or response validation is where it becomes that potential injection point. A lot of times we see some fun stuff with like response codes in particular. So if a application or your forged request makes like a post request, but you want it to essentially make a GET request, for example, you might be able to give like a 301 response, which will just transform the request into a GET and then send it off to whichever location. Essentially meaning that we can have a little more flexibility as far as options as where we want that request to go and how that request to be structured.
So attacker server response 301, and that redirects, again, your web app server. Now you're doing a GET request.
Yep, and also sometimes a way to get around input validation as well. If input validation restricts an internal domain, say we're not allowed to do organization.com, but we can do attacker.com. If we make a request out to attacker.com and then have it redirect to organization.com.
Back to that secondary injection point when the response comes out, you control. Maybe you don't get the original GET request coming out of the web app. You say, hey, 301, and then it's like a GET request.
Yeah. So there's a lot of areas as far as how the HTTP client can be configured for protection as well. Excessive network access almost comes down to, again, firewall rules, egress permissions broadly being almost always allowed outbound to at least HTTPS, HTTP, DNS type services. And then again, weaker missing authentication, there we go. Some other examples are if there's like internal services using like basic authentication. With this user info field, we can actually do like password spamming against internal systems because we can pass username :password at whatever target, and we can essentially then chain SSRF into like a password spamming attack. So lots of honestly like pretty easy mistakes to make as a developer when you're trying to defend against these types of vulnerabilities. And also lots of like very challenging situations because, as I mentioned before, a lot of times there's business purpose and like business need for this to happen to support your APIs or to support your website. So yeah. Okay, you're gonna differentiate synchronous and asynchronous real quick.
Okay, so I talked about the first diagram. I'll talk about this diagram too, where we kind of introduce this consideration for asynchronous workflows. So on the left, we have the normal synchronous application. I think hopefully we can understand that with the pretext that we've talked about so far. On the right, we have a consideration for asynchronous workflow. So maybe you have an input validation issue, you put attacker.com in there, or you put your collaborator in Burp Suite, because that's easy to use. I think a lot of us might be familiar with that. Just basically attacker.com, where you can see the access logs to see if the server's hitting you. And that doesn't happen right away, and you think, oh, okay, well, it doesn't do an external interaction. Leave that attacker server open for a bit, because maybe that domain name goes into an SQSQ or sits in the database for a while and there's a nightly job that runs, and then it reaches out to, and this is pretty common in webhooks. I think a lot of times they're asynchronous. You're like, hey, here's where my webhook is, and then it, every 15 minutes or whatever reaches out, tries to do auth, or maybe there's another, you store that URL in the database and then you go like, connect or you finish, right? And then that's when it reaches out later. So in this case, it's at least going to be semi-blind, right? Because we're not, I don't think you're not holding the HTTP connection open for that long. So you're never going to actually see that response in an asynchronous workflow, because the server will finish your request. Say, yep, I got it. I put it in the database. Yep, I got it. I put it in the SQSQ, and I'll deal with it later. So then we just have the next control injection point, which is actually the going downstream, right? So what is the response from attacker server whenever that asynchronous workflow does pop off? Cool.
So yeah, so we kind of differentiate between synchronous, asynchronous. What does the downstream portion look like though? And really the key takeaway from this slide is that stuff can happen later on, even beyond our forge request type interaction. And a lot of times, if it's an asynchronous workflow, like we don't know what's happening. And one of the key parts, in my opinion, of like fully understanding an application is to know what happens in like replicating like end-to-end scenarios. Because then, if we don't do that, like there could be stuff here that we want to be like playing around with or like inspecting, and we just don't have that visibility. So if we were to kind of go through a scenario like this, we would kick off our our initial payload in step 1. The target server that we're testing would reach out in step 2, and it'd just be an immediate response because this is an async workflow, and that workflow doesn't change the initial response back from our service we're testing. But then at some point in time later, it reaches out to its third party, and then that third party responds, and maybe even more stuff happens. So in kind of like the quote-unquote case study that we're going to be doing, we tried to essentially, and we succeeded in essentially I kind of gave a spoiler before, essentially doing a machine in the middle attack by essentially miniming the HTTP like interactions between the expected third party and then the service we were attacking. And we were trying to essentially explore this downstream portion here because we had no visibility into it. And this was kind of an interesting case because a lot of the tools that testers commonly use, specifically like Collaborator, kind of have very specific behavioral patterns. And if we want to reach this scenario, I guess it's kind of blurry, step 7 and 8 down at the bottom, if something fails before that, then steps 7 and 8 may never happen. So again, we need to make sure that the expected end-to-end sequence completes fully as expected in order to get to step 7 and 8 here in the first place. So if we're using something like Collaborator and it's always going to respond with just like a string, or I think like an HTML string containing the subdomain that it used, then that response structure for the third party, it will not match what the target server is expecting, and it might just cause an exception, might just kill that workflow, and then where we want to go in step 7 and 8, we never get to it. So, Collaborator has a couple constraints. I'm going to jump forward 2 slides just to explain really quick just how did we get around this. And honestly, it's not a really complicated process. Essentially, we're just going to receive an inbound HTTP request, and then we're just going to duplicate that request out to the expected party. And then once that party responds, we're just going to duplicate that response and send it back to the target server, which originally made the request. Which again is just an example of a machine in the middle attack between 2 exposed components. So this is just what's happening in our little script that we put together. There's a couple other useful endpoints. We talked about the response code kind of fuzzing, which is something that was handy as well. So there's a couple little more APIs that are useful. And when we do this ends up looking a lot like this type scenario, which it's pretty clear to see that it's a minimum type attack because we've placed now our local testing system, which it's like a tie back from our remote testing system into the middle. So the prerequisite here is that there needs to be some sort of public system that both the target server and the integrated third party can interact with. So our solution there was just to I think we just spun up an EC2 instance, and then we just did a quick SSH tunnel. And the purpose there is that we want to see what's going on, and we want to be able to tamper with it. So we're just going to proxy everything both through our remote testing system and then also back through Burp Suite. So essentially, everything's going to hit the remote testing system. It's going to come back through Burp Suite. We can play with things on the fly, and then we can just send it off on its happy way. So in our kind of case study, we first set up our tunnel. We saw initial request kind of contained our very first SSRF payload, and this was an asynchronous workflow. So that server gave a response back to our target. That's step 3 here, pretty much immediately. And then at some point in time later, that server reached out to our remote testing system. That proxied through Burp. We threw it to the expected third party. And then we had this concept of a forged response. So we saw some very interesting looking parameters in the response from the third party, which we kind of got excited about.
Additional SSRF.
Right.
Another URL coming back from the integration.
Yeah, and the demo will kind of mimic this a little bit to some extent. But essentially, we saw some very interesting parameters come back from the response, and there's no controls that were in place that prevented us from just playing with them. So we similarly just put our, MIDM proxy as the target for that, response parameter, and then we sent it back to the target server. And essentially, this ended up happening such that there was 4 or 5 kind of steps in the workflow, and we were able to MIDM all of them, which ultimately resulted in us, and fortunately, we saw authorization tokens, not only compromising the target server, but compromising the third party because we were able to extract the third party's authorization tokens as well. So it was kind of an interesting example. Figured we'd do a talk about it. And then also kind of just raise the question of how do we play with the responses, and how is this considered as far as injection points into applications, and like why are developers, you know, perhaps not as aware of the fact that those responses may also be malicious. And not saying that they aren't, but I think, as I mentioned before, like that core input validation almost always gets applied to the first request that you as a user makes to an application. Then after that, if you're working with a third party, you probably expect there to be a certain amount of trust there. So that's pretty much what happened here. I think we're ready for our demo walkthrough, which is essentially a silent recording, which I'll just be doing a quick voiceover for. And this starts like very basic. We're gonna like show in like a very happy case, what does SSRF identification look like? So if you're not familiar with the tools, I'll kind of try to give like a quick overview about what we're doing here. And then before it gets into the juicy details, I'll also explain like the lab setup. Yep, and I'll probably actually like pause it here. Sure. Okay, so just to start up our demo, we have like 3 tabs in the terminal here, the left, middle, and then the right being the target, the receiver, and then the integrated third party. Those systems are .245, .246, and .247 respectively. So when you see that pop up later on, that's kind of what those are. The .251 is our testing device. And what we're doing here first is setting up that SSH tunnel so that our receiver comes back through Burp Suite. The important thing here is that we need to make sure that the port that the receiver forwards to is the same port as the burp listener. And then once we set this up, the port that we forward from is just going to be the same port that that tool is listening on itself. So for our demo, we have a couple APIs, and then if you want to pull it and kind of play around with it, this will be what you see. And then these are just APIs that some applications exposing. So we can see that you just call our APIs as we would as a pen tester. We're just first replicating that end-to-end kind of happy path. And eventually we'll get to a point where we see interesting parameters. Getting a little bit ahead of myself. But that interesting parameter is going to be like a URL. And whenever you see a URL, one of the first things that snaps to you is like, can it cause SSRF? So obviously it's a demo, so obviously it's going to be vulnerable, and we'll see that pretty quickly. And then the first step here is just like, how do you confirm it in a typical case? And we're going to use Collaborator to do so. So let the demo catch up here. It's kind of just showing the interactions with the back end. This is showing how, first we make a request out to the target, and then the target interacts with the third party. Now we're going to drop in a Collaborator payload. Then if you want to pause here. This is a great example of a transparent SSRF type situation, because you'll notice that the response differs from especially the expected response. So the target server on the left has reached out to Collaborator. Collaborator is our, currently our remote testing system. Collaborator responds with its subdomain, which is just that little string payload in the bottom, and then that target returned that to the local client. So transparent SSRF in that not only do we see the request out to Collaborator, which will be shown shortly, but we see the response that it's made as well. Okay, so yeah, if you're not familiar with Collaborator, this is what it looks like. Essentially, we get to see the request as it comes in, and a lot of times we're really interested in authorization headers, any sort of sensitive information. And this is just an example of seeing exactly that.
Collaborator is basically the access log for the web server reaching out with the Collaborator.
Sure. This portion is just going to show like what is that tool doing in the background, because next we're going to use their tool to actually admit them the connection. The important thing here is really just extraction of the destination so that we can overwrite the host header in the request. Because a lot of times there could be like routing rules based off the host header, and if that doesn't match, we have to like make sure that's the correct value in order for it to be routed properly. This just shows that intercept proxies is just that way to get back to Burp Suite for the tool. So this is our receiver host, and essentially when we send our next request, we should see an interaction with the receiver, and then we should also see both the request and response pass through Burp Suite as well. payload structure using the tool is just leading with your receiver fully qualified domain. Then you'll do /intercept, and then you'll actually put the full URL that you want to forward off to, including the scheme and everything. And when we send this off, kind of just showing that HTTP history is currently empty. Make sure request partner documents, we intercept it, and then that system has received the connection as well. And we should see that as well in burp. So there, we see the request and response passing through burp. So now we've effectively done a machine in the middle scenario, and now we can start playing with it and tampering with that request and response. I believe this is a portion of the demo where I made a mistake and didn't have the right settings, so I'll actually show how to adjust the burp proxy such that you're able to tamper with those responses, which I guess is kind of handy because we can just show that. Essentially, we're going to turn on intercept responses, and then for this one, I just check an option that says if the request was intercepted, then I just want to like hold the response as well. In like a real situation, you'll probably want to have that a little more constrained, specifically on like the types of requests that you're interested in. Otherwise, you'll just be like really backed up in the proxy as well. So this is an example of just modifying that request, and we can see that kind of tampering did occur. For this one, I don't show any sort of like vulnerability as far as like exploitation using that response, more just a proof of concept scenario. This next section is that asynchronous workflow. So we fire off a request, and then in the response in burp, it comes back almost immediately. But then we see our interaction afterwards. If you want to pause now. Okay, so there's a couple things that happen here. First off, we see a /, probably a little hard to see for most folks. Essentially, the service makes an initial request after this synchronized action. And then at some later point in time, we saw another interaction to this synchronize /other path /acknowledge action. And this is that downstream asynchronous type behavior. So that third party interacts with the target server at a later point in time, but if we're just testing normally, we have no idea that this is happening. Like this is kind of, oh, okay. Yeah, we're kind of blind to this interaction. I think we'll be fine. We can kind of go again. And this is kind of just going to show that if we're using collaborator in this situation, as we mentioned before, collaborator will kick back the subdomain in its response, and that workflow will break. So we'll see the initial request, but we won't see that second one. So the workflow broke. We have to essentially do a midim in order to get that working properly, and then we can explore what that workstream looks like. So there's our request, and this is kind of that super interesting parameter structure. It was called like a callback or like a partner URL. Essentially, we saw another URL within the request, and we're like, definitely want to try and SSRF that as well. So that's what we'll do here. We'll first send it through our receiver. I really took my time on this, didn't I?
SSRF mitigations.
Right.
SSRF is SSRF.
Okay, so now we're going to send it off. And we saw, okay, now we're doing a midim of that initial workflow. Now we need to, again, intercept it, tamper with the other requests. That way we can get into the third party action. There we go. Okay, so this is actually tampering with the request itself, not necessarily the response as the injection point, but still kind of just doing that machine in the middle situation to get a different malicious payload out to our third party. And here we see one action occurs, and then this action occurs, which is actually from the third party. So in that scenario, I think should have shown, you would have noticed that the authorization token was different. It's actually the authorization token of the third party server, which is pretty important, especially considering that any sort of work stream by one party may affect third party if there's not strong controls on both sides. So key takeaways here. SSRF is really cool. There's a lot of like shenanigans as far as points of failure and like interesting things that you can do. B, if you can get a request outbound to yourself, absolutely try and like do a machine in the middle scenario. You might see other downstream workflows which can be occurring without your knowledge, and then you can play around with that. And then C, consider the response content as an injection point as well as your initial requests. Because, you know, first off, there might not be as strong input validation because there may be implicit trust. And I guess it's also just kind of an interesting concept. So. Right, I think that pretty much gets us there. Yeah, any questions from folks? As a hand back there. Yes. Between CSRF and SSRF, the synergy between the two.
So it's the same idea, but one happens on the server, one happens on the client.
One happens on the server
So the server's
side,
actually
client
making
side.
this request, not the front end browser. So that's powerful because the server's in a different network position than maybe the client browser. Yeah, the client browser is also in a different network position, but it's probably like someone's home. What do they have at home? You know, you're more interested in hitting something in their infrastructure, like, oh, they have IMDS magic bits to get cloud credentials. They have hitting their firewall. You know, you're interested in the network position of the server because there's other databases and other things in the server's infrastructure.
I think the synergy that you mentioned, though, is that you absolutely could, in theory, minim a CSRF connection. You're just not miniming two backend servers. You're miniming the user's browser as well as the target. Also, very interesting.